السلام عليكم ورحمة الله وبركاته. يعطيكم العافية شباب وصبايا. Our video for today is Fluid Mechanics Part 3 from Chapter 13. And the subject for this video is about the variation of pressure with depth. As you can see here, I have a container, and this container is filled with a certain fluid or liquid. Assuming we have an object, and I will take this object like a cylindrical object, and this object far from, or the distance of this object from the top of this object to the surface, which we call it H1. The distance from the surface of the fluid to the bottom of this object, which is H2. So it's clearly the height of this object will be H2 minus H1. Now, this object will experience two pressures, as you can see here, pressure from the top and pressure from the bottom. If we go to Newton's laws, we can say the following. We have three forces acting on this system. Force from the top directed all the way downward, the weight of the object directed all the way downward, and the force from the bottom directed all the way upward. Now, our system here is in equilibrium. So we can say the following. The force from the bottom equals to the force from the top plus the weight. Therefore, we can say F bottom minus F top minus W equals 0. As we know, we can use the definition of the pressure to calculate the force, whereas the pressure equals force divided by the cross-sectional area. Therefore, we can say F bottom, which is pressure bottom times area, F top equals pressure top times area, and the weight, which is mg or rho vg. And let me say the following. For this one, we are not dealing with masses. In a fluid, we are not dealing with masses. We are dealing with densities. That's why I converted, or I used the definition of the density instead of the mass. Now, take these values and go back to the main equation. You will get the pressure at the bottom minus the pressure from the top, which is the atmospheric pressure, equals rho gh, whereas rho gh is the gauge pressure. Now, let me go back with you to chapter 10. I'm pretty sure you can relate this equation or this formula with chapter 10, where we said pressure inside minus outside pressure equal gauge pressure. Therefore, if you compare this to that formula, you can say the pressure at the bottom, which is the same as the inside pressure or same as absolute pressure, the outside pressure or the pressure from the top, which is the pressure due to the atmospheric, and rho gh is the gauge pressure. Example number 1. The surface pressure on the planet Venus is 95 atmospheric. How far below the surface of the ocean on Earth do you need to experience the same pressure? Whereas the density is given. As we know, the pressure at certain depth equals P naught plus rho gh. Now, rho is given, g is given. We are calculating for h. So from here, the pressure from here, we have only one unknown, which is the depth or the height. Now, from the question, the pressure at the pressure or the total pressure, which is 95 atmospheric. So here, 95 equals 1 atmosphere plus rho gh. But be careful. Up to this point, you need to convert from atmospheric pressure into Pascal to get the height in unit of meter. Second example, on a particular day, the atmospheric pressure was 10 to the power 5 Pascal, and the density of seawater is given. 1. What was the pressure at this depth? Okay, we know the pressure at certain depth equal the atmospheric pressure plus rho GH. Now, height is given, G is 10 meter per second square, the density is given to, and the pressure, the atmospheric pressure is given to, so we are calculating only for the total pressure or the pressure at this depth. Second, what was the gauge pressure? Now to calculate the gauge pressure, we know gauge pressure equals either rho GH, we know rho, we know G, and we know H, or the bottom pressure minus the atmospheric pressure, as you can see here. Third example, a certain pressure can support a column of water at certain height. If the same pressure supports a second column of a non-liquid or fluid of 800 kilogram per meter cube, at what height the unknown fluid will have the same pressure? Okay. This question is kind of tricky. We are talking about two columns, each one filled with different fluid, but both of them have the same pressure. Therefore, we can say pressure at the first column equals to the pressure at the second column. And we know the pressure at certain height, which is P naught plus rho GH. So we can say P naught plus rho GH1 equals P naught plus rho GH2. Now we are going to calculate the second height, where is the pressure at the first column equals the pressure at the second column. So from here, do your calculation, you will get H2 equals rho1 divided by rho2 times H1, whereas rho1 is given, rho2 is given 2, and the first height is given. So you will get the height, or the height of the second column, or the fluid inside the second column, will be 1.125 meters. Fourth example, for an ocean surface, at what depth from its surface the pressure becomes twice of the atmospheric pressure? Again, we are calculating, or we are talking about pressure depends on depth, or variation of pressure with depth. We know the formula, which is P equals P naught plus rho GH. Now we are going to calculate the depth, which is H. So we know the density, we know G, we know the atmospheric pressure, but be careful. The pressure here, this one, the pressure at the bottom, or the pressure, the absolute pressure, as given here from the question, says the pressure become twice of the atmospheric pressure. So you have to say P equal to P naught, which is 2 atmospheric pressure, and be careful, we are looking for height. So you need to convert from atmospheric unit into Pascal or Newton per meter squared. Another example, what will be the gauge pressure and the absolute pressure of a water at depth 12 meters below the surface? Okay. The fluid, or the liquid here, is known, which is water, and we know the density for water, which is 1,000 kilogram per meter cube, and we know the height, or the depth, which is 12 meter. So the gauge pressure, which is rho GH, you will get 120 kilo Pascal. Second, what is the absolute pressure? We know the absolute pressure, which is P naught plus rho GH. We know P naught, which is the atmospheric pressure, and you have to convert it into Newton per meter squared or into Pascal. Rho GH, which is already given. So you will find the absolute pressure, which is 220 kilopascal. Thank you so much.